Okay, today we're going to talk about synaptic transmissions. When two neurons talk to each other or interact, they get very, very, very close, but they do not touch. That tiny space is called the synaptic cleft or synaptic gap. In this image, we have our presynaptic neuron and our postsynaptic neuron. Our presynaptic is sending the message to the postsynaptic. So when action potential from our presynaptic neuron hits the axon terminal, little sacs called vesicles or synaptic vesicles are holding neurotransmitters. These little dots are neurotransmitters. When activated, the vesicles fuse with the presynaptic membrane and the neurotransmitters are then released into the synaptic cleft. This is a process called exocytosis. Some of the neurotransmitters will then connect with the receptors of the postsynaptic neuron. And again, this is the dendrite of the postsynaptic neuron. Now, there are over 100 different types of neurotransmitters, and that's actually still being debated. But for the most part, they're split into excitatory and inhibitory. What that means is they'll either encourage the next neuron to fire off or they'll tell it to stop. Think about if you get a cut on your hand, eventually it hasn't healed all the way, but you stop feeling pain. That's your endorphins, which is an inhibitory neurotransmitter. So after the neurotransmitters have done their job, one of three things will happen to help clear them out of the synaptic cleft. The first is that enzymes can appear and they break down specific neurotransmitters. The second is a process called reuptake. This is where the neurotransmitters go back to the presynaptic neuron through a transport protein. The third is diffusion, and that's literally where the neurotransmitters just kind of drift off. Once the neurotransmitters have been cleared from the synaptic gap, then this synapse is free to fire again. And that is synaptic transmission. If you have any questions or comments, drop them below. Bye.